Here we have a mouse brain. These red cells are the osmosensing cells. The blue neuron here is the magnocellular neuron. The median eminence extends from the hypothalamus, which is where these cells are, into the pituitary gland via the portal connection. The blood-brain barrier, which is specialized endothelial cell lining the capillaries in the brain, keeping the closed system, is almost non-existent here, as all the capillaries here are fenestrated, which allows for the hormones to flow easily in and out of the blood. There are 5 key releasing hormones that are released into the median eminence, starting with the corticotrophin releasing hormone, then growth hormone releasing hormone, gonadotrophic releasing hormone, prolactin releasing hormone, and thyroid hormone releasing hormone. These are all releasing hormones that only act as hormones to trigger the trophic cells to release the endocrine hormones. These releasing hormones travel into the anterior pituitary gland where they will meet their respective trophic cells. Gonadotrophs and GnRH will bind together to release both the luteinizing hormone and follicle-stimulating hormone. Both of these hormones have an effect on female reproduction. The somatotroph cells will bind with the GHRH to release growth hormone. The lactotrophs will bind with the PLRH to release prolactin. The corticotrophs binds with CRH to release ACTH. And the thyrotrophs bind with TSRH to release TSH. Moving on to the anatomy of the female reproductive system, here's the uterus, fallopian tubes, and the ovaries. These ovaries are attached to the uterus via these tendons. In the ovaries are tons of these primordial follicles, which are essentially just germ cells or oocytes. Once a month, 7 to 15 of these follicles will turn into primary follicles. These primary follicles begin the production of estrogen. They begin to take shape having one layer of these granulosa cells in blue, and then a layer of the purple cells, which are thecal cells. At this point is when the luteinizing and follicle-stimulating hormone come into play. They induce the thickening of these follicles in the functional layer of the uterus via the granulosal and thecal cells. The primary follicle transitioned then into the secondary follicle, which will have a thick layer of the granulosa cells, still with the thin layer of the thecal cells. Also present now is this follicular fluid sac. At this stage, even more estrogen is released. Those same hormones continue to then thicken both the follicle and the uterine lining. The final follicle stage is the antral follicle stage. At this stage, the granulosa cells are as thick as they'll get, while at the same time the uterus is preparing for implantation. In the antral follicle, the follicular fluid sac is even larger, more estrogen is produced, and the oocyte has now become a haploid oocyte. A surge of LH causes the antral follicle to rupture and then send the oocyte into the fallopian tube to be fertilized, while corpora lutea, these yellow cells here, are released from the follicular fluid and cause a surge in progesterone, while estrogen is also declining. Here is just like a graph of the different concentrations. LH is defined as ovulation, which would be here. If implantation does not occur, menstruation will occur, which resets the whole system. But if it does occur, an embryo will be embedded into the lining of the uterus with its own blood supply, there to thrive and grow. Menstruation would take place in the shaded off area of the reproductive phases. The follicular phase is typically day 0 to 14, the luteal phase being 14 to day 28. And the follicular phase is where all of the big stuff in the ovaries occurs, while estrogen progressively increases and peaks at the time of ovulation as well, decreases and then goes through another surge, while progesterone is also surging. The endometrial layers here, they have a constant basal layer, and as the estrogen begins to thrive, the functional layer becomes thicker, allowing for the uterine lining to get its own blood supply and become a primary place for implantation.